Hello everyone, so this is going to be lecture 3, functions, recursions, and I doubt I'll get to the next part because this chapter is a long one, chapter 6. We'll see how far we get in this one. Um, but before I start with uh, this chapter, let me go ahead and wrap up some of the other topics that I didn't cover. Now, next up I have for you is the logical operators and expression. And when it comes to the logical operators, there are three: and, or, and not. Okay? Um, and this is probably the most confusing operator, but bear with me. When we go through the examples, it should make sense. And the way those are denoted, and is denoted by two ampersand, or two pipes, right? Not is an exclamation mark. And if whatever is on the left and the right, both of us is true, then the and is true. Otherwise, it's false. If either one is false, the whole expression ends up being false. Or if either one, what's left of it and what's right of it, either or is true, it ends up being true. Not whatever is the result, it's going to reverse it. So if it's true, it's going to change it to false, and then vice versa. That's as I was saying, so keep this in mind. And is only true if both are true, or it's a little bit slightly easier going. Either is true, it's going to be true. That if you take the not of the whole expression, it's going to flip everything. If it's true, it's going to flip it to false. If it's false, it's going to flip it to true. Now, look at this example right here. I've got A is equal to 5, B is equal to 9. And then I say, I'm checking A equals 0 and A is greater than B. What's going to happen? A equal to 0? No, it's going to be false. Is A greater than B? Well, it's not. That's false. So false and false is false. Second one. Now you can even output this. Second one. A is equal to 0. Yes or no? No, it's false. And is A less than B? Well, A is 5, B is 9, so that is true. So false and true is going to end up still being false. And now the next one. Is A equal to 5? Yeah, sure, it's true. And if A is greater than B, well, it's false. So true and false, still false. Last one. So you're seeing, right? Both of them's got to be true. So the last one, A is equal to 5, yes. Is A less than 9? It's 5, so yes. So true and true is true. So the only way you're going to get true from an and is if both the statements are true. Now, keep this in mind, is when you're doing this, this is a simple example. You can have uh, a series, a whole line of trues and false, right? And then that is gonna really make things more complicated. But if you divide them up and go walk through this way, is if you've got so many ands, if one of them is false, everything's gonna be false. And then for or, if you've got several ors, if one of them is true, the whole expression is gonna be true, right? And if you not it, then it's gonna change, flip everything around. How about the or? Okay, like I said, if both are false, and if you don't know this yet, in ones and zeros in the binary role, 0 means false, 1 means true. Okay, so in this example, only the first scenario is false and everything else is true, right? But in the other scenario, only one was true, everything else was false, because only one side's got to be true. Right, so in this case, A greater than B, nah, But A is equal to 5, right? Yeah, so the whole thing becomes true. A equal to 0? No. Is A less than B? Yeah, so the whole thing's going to be true. Let's look at not. So I've got A equals to 5. Then I'm saying, is A equal to 0? No, it's not, so it's false. So if I say not, what's going to happen? It's going to flip it to true. Right? Is A equal to 5? Yeah. Right. And then if I flip it, it's going to end up being false. Okay? So first one is true, second one is false. Hopefully that makes sense. If not, you can always contact me and I can help you out in my office hours or set up new office hours for you. Continuing on. So keep this table in mind, right? So for OR, as we talked through examples, the previous example, everything was true except one was false because, right, either the left or the right's got to be true, and the whole thing's going to be true. The equality is equal to, not equal to, less than, greater than, less than or equal to or greater than or equal to. Now, one thing to keep in mind is the equality in C++ is denoted by 2 equals to sign, okay, which is the first one right here. And then the second one is not equal to. What do I have? That is, do an example of not equal to. Yeah, this one is an example, but one thing to keep in mind for 2 equals to sign, it's really important because if you're checking for equality and you don't use 2 equal to sign, then this is going to happen. So in this example, I've got int I, int j. One's 1, the other one's 2. And what I really want to do is I want to check if j is equal to 1. So I say if j equals to 1. But I only used 1 equal to. What do you think is going to happen? Let me run this program. Using name space std. Oh, this is the C compiler. So many typos, I cannot type here for some reason. Include IOS compilation terminated. So if I've got, oh, this is the C++. Anyways, instead of having me to copy paste all of this into a different one, what I'm trying to say here is, well, what the heck? You guys deserve good examples. Now, hello world, the value of j is 1. Well, it was 2. See, what happened is, if I only use 1 equal to, it ends up being an assignment. It'll do j equals to 1, which is going to be true, and then it's going to change the value. But you really don't want that. This is what you wanted, right? If j is equal to 1. It's not going to execute because j is 2 and I is 1, right? That's the first example I wanted to share with you. I've got a few different examples. Okay. This one just refreshed all of my examples. What a bummer. Okay, never mind. Let me continue here and I'll pause and get better examples. So, okay. So next up is, look at this, what happens. 2 equals 2 is equal to. So 3 equals to 5? No, it's not. So it's going to give us false and not equal to example. So is 3 not equal to 5 is going to give us true. because 3 is not equal to 5. Is 3 greater than 5? False again. Less than gives us true. Greater than or equal to gives us false. Less than or equal to gives us true. So now this is actually hinting to the next set of examples or next section that is going towards, which is expressions, right? These operators, they check relationship between two expression, right? Or operands, you can say, or whatever you want to call it. Whatever's on the left of it versus whatever's on the right of it. It compares the relationship between the two and it spits out true or false. Okay, so now we can continue on with this chapter. Let me go ahead and get started here. Now, like I said, this chapter has a lot to talk about. So many things: library, math, math library, and libraries, recursion, functions, random numbers. So first up is, you know what? Let me take a step back here, and the book mentions the library, math library functions, and then talks about the built-in library. So let me change the order. So C++ comes in, it has all these built-in libraries for you that you can use. I think there are about easily 100 or more libraries. These are just some of the libraries that's available for you to use. Now, if you recall the syntax, include IOStream. IOStream is a built-in library that has all the functions available for you for input and output. So IO, input, output, stream, that's what it's for. There is the array, library, vector, um, DQ, list, set, map, unordered set, unordered map, iterator, algorithm. So these are all these libraries that's available for you. I'm not going to cover each and every one of them, but you can look up a library in C++ and see what method it has, and then go ahead and start using it. It is highly efficient, highly useful, and it comes in handy. And one thing to keep in mind is C++ is built on top of C. So whatever C had, C++ also has it, um, and more, right? So you can use a built-in C library, but if you really want to do that. Let's go back. Now, one of the libraries that's included, that's built in, is a math library. Now, once again, that comes with a whole lot of functions, methods, but I'm going to cover just some of them. ABS, absolute of x, it returns the absolute value of x. Let's say if you get a decimal number, floating number, 2.8, 7.8, whatever, it's going to return 7. Um, Whatever, cosine, sine, exponential. Oh, the other thing, okay, fabs, right? Um, returns the absolute value of a floating number x. So there's a slight difference between absolute and then um the absolute of a floating number. There is also the ceiling, returns the value of x rounded to the nearest integer. So ceiling, there's also floor of x. So if you have 2.6 and you say the ceiling, it's going to say 3. But if you ask for the floor, it's going to give you 2. Ceiling is upper bound, um, floor is lower bound. So just I think the absolute value one is one that I've used. Ceiling and floor I've used. I'm not gonna test you on all of these methods, math library methods. If you're interested, go right ahead, be my guest. But let me walk you through some of the examples. So here I've got an example. I'm using square root. That's also a built-in method. Log, logarithm of 2, ceiling of 2.6, floor of 2.6. Now, before you can use any of these functions, you ought to, you should include CMath. And let's go ahead and run this. You probably saw the output, but what the heck, let me just run it again. So square root of 64 is 8. Log 2 is 0.69. Rounding of 2.6, you're asking round to the nearest integer, it's going to be 3. Ceiling of 2.6 is upper bound, right? So ceiling is going to be 3, whereas floor of 2.6 is going to be 2. Okay, I hope that those are clear. One thing I ought to mention, if it's rounding to the nearest integer. So let's say if it was 2.4. What do you think is going to happen? Which is the nearest integer? See that? 2, because that was the nearest integer. How about 2.5, right in the middle? What do you guys think is going to happen? 2 or 3? 3. So anything 2.5 or higher is going to go towards the higher bound of rounding up the number. What else do I have here? So next up we have a function, but let me just go ahead and mention some of the things about functions, why I need them, what's the point of having it. A software, a module, is broken up into smaller components, right? One of the component is function. Now imagine if you had to do something over and over and over again in the program, right? Let's say you had to add 1 for every user input, or add 1 to something, or do any mathematical computation or whatever you had to do. Now that if you've come across a point where you're having to repeat the lines of code over and over again, stop right there. Use a function or a method. What's going to happen is the repetition of the code is going to go away, and you're going to call the method. You'll see the method name again and again, but that method is going to have multiple lines in it, and that's going to save you. It's going to reduce the number of lines of code, and then it's going to increase the readability of the code. It's going to make it easy to read and understand, and it's also going to make maintainability of the code a lot more easier, right? If you've got repetition of lines, you might make a mistake here and there. Debugging is going to be hard, but if it's a method call that you're calling again and again, then there's an issue. You're going to see that issue every time you call the function. The next thing is the prototype. How do you write a function? The syntax is you have a return type and you give it the name of the function and then the parameters. There's no limit for the number of parameters that one can have. You can have as many as parameters as you wish, although I don't think I've seen more than 10 parameters used. And you can have 0 parameters. So if you get 0 parameters, after max, let's say in this case I've got max, it's gonna be open and closed braces. That's all that's gonna happen. But you must have a return type. This is a return type. Actually, there should be no space. That's a mistake on my part. Int return underscore max. It should be one word. So the name of the function, one word. Must have a return type, parameters 0 to n. And if you don't have a return type for a particular method, you can say void. Okay? Okay, now continuing on with functions, there are 2 types of functions. One is the functions or methods from the that are built in, right? The math functions that you saw, those are included as part of the library that you import. And then the other ones that I was trying to mention is which is the user-defined function, right? So you define them yourself, you define the behavior. Although the built-in functions are there, but they're not exhaustive. They're not going to cover each and every case. I mean, maybe you need a function to output hello world, void greet. Okay, now here, keep this in mind when we're talking about the return type. I said, right, if there is no return type, you are going to return nothing. You can say void. And in this case, it's going to output the hello world. And the way you call a function is something like this. So in your main, you would have a list of commands, and one of them is going to be greet, right? So you have the method defined up ahead, void greet, and then you call it just by the name and the arguments. In this case, there are no arguments, so you just had greet over there. Um, and the way it it works is you're gonna in your main function you're gonna go through the lines of execution in the code, and when you call greet, greet goes back and calls the this method right here, void greet. Okay, so the control of the program or the processing is transferred from here to here, and it executes all the statements that are within greet and then comes back to this one. So that's how it that's how it actually works. You know, it's funny. Whenever I start lecturing, I dry up and I have to drink a lot of water. Okay. Um, Now let me share some examples with you. In this one, I have a display num example. There's always some advertisement in this online compiler. Can be distracting at times. In here, I have a display number that takes in an int and a float. Okay. And another thing that I ought to mention here is when you choose the name of a method, make sure it's something that describes its functionality. The name should be clear enough, and obviously you're gonna have comments, etc. But the name is a key, right? You don't want to have void ABC, and when someone looks at it, be like, "What does ABC do?" Hey, it displays number. And another thing to keep in mind is you can do this for a void function. Okay, you don't explicitly have to have a return there because the compiler knows, but in this case it's a void function, it's going to return nothing. Let's go ahead and run this. The int is 5, the double is 5.5, right? So I had an int here and a double here, and I call the display number num1 and num2. And see what happens. The couts are here. So what happens over here when you could display num? The control went up to the top right here. Right? So I hope it's straightforward. What else do I want to mention here? Yeah, I think that's a pretty straightforward example. And there's no difference of having this. I'll take it out too, okay? I didn't have it there to begin with. It's same output, same result. No difference. Here's another example of a function that adds two integers. So I have int add that takes in two arguments, and then it's going to return the sum of it. Now you see the way the method is written, it says return a plus b. I mean, you could have had a placeholder int, right, and then you add and then you return that particular number, but this is short way of writing it. Right, so sum of 10 and 78 is the next few examples, let me cover something here. So the next few examples, I'm going to talk about function overloading. It literally doesn't mean you overload the function and it cannot handle something. What it means is it's the same name or different arguments. Okay? You can have a different return type as well. So I have an int test. The first one takes in no arguments. The second one takes in one argument, right? And then the float test return type is different, and then the argument is also different, right? So this is called function overloading. It is where you do different things for a function with the same name. Different arguments, different return type, it's all called overloading. The next few examples is that's what I'm going to cover. So I have a method called absolute, and I'm going to have two versions of that method. Float absolute, int absolute. The float absolute takes in a floating number. The int absolute takes in an integer number. And it checks if the input is less than 0. If it's less than 0, then var equals to negative var. And then just returns that negative var. What does it do? Get the point here? So it tells the absolute value of the number, regardless of it being positive or negative. And these are two overloaded methods. Okay. So as far as you know the syntax of it, you'll find overloading very, very useful. I mean, you're gonna come across when you're gonna use this overloading. So you're gonna come across a situation where someone else had written a method already. The method works, everything, logic works, computation works, but you gotta add another parameter to it. Well, you can take whatever is existing and manipulate that, copy paste it, add another parameter, and build on top of that function. So overloading is a small, straightforward, yet a very powerful tool in programming. Okay, so hopefully things are clear up to this point. Functions, function overloading, and why you use them. I might ask you in the midterm, what's the point of having functions? What's function overloading? Good. Another example, same function, same return types, but the parameters are different. Okay, so in this one, I've got 3 display. First one takes in this one takes an integer and a double. Okay, next one takes in a double. Third one takes in a int. And then in my main function, I've got an int and a double over here. And then I have display A, display B, display AB. And keep in mind the flow and how this is going to go. When you call display A, right, with an integer, which one is it? It's this one. So it's going to output integer value and then come back. Display B. B is a double. It's going to go here. Output double number and then come back. Finally, display AB. It's going to go to the very top and then it's going to come back. Right? So the flow is changing. See, integer number 5, double number 5.5, integer number 5, and double. Now we talked about these variations. What if the user doesn't give any parameters to a function, and what you're trying to do, okay, what you want to do is you want to assign default values. So the arguments that the function is supposed to take, those are default values, and if the user doesn't provide them, you assign a default. Well, how do you do that? I'm going to use the display method here, and display method takes in a character and an integer. And the character is an asterisk, integer is 3. So both of these are default values. Okay? And then I say int count equal to 5, and then I say no arguments being passed, and then you display. One thing I ought to mention is, why do I have display up there and then the actual implementation down here? What do you think? So if you don't have that display up there, compiler doesn't know about display. So what we do is, hey, we tell the compiler, there is a method called display whose implementation and the nitty-gritty details you'll see later on, so it's not confused. And this is where it is. And what it does is it goes from I equals 1 to count, and then it outputs the character, the asterisk, that many number of times. straightforward, right? Now let's go ahead and run this and find out what you get. Number of arguments passed, 3 asterisks, 3 pound, $3. What's going on here? First one, there was no argument passed. What's going to happen is the default argument of 3 would have been passed in there. Well, it would get default of 3, and then the star, the asterisk, I'm sorry. So 3 is the count, 3 is the number of times it's going to output the character, and since it's all default, it's going to put asterisk 3 times. Now the next time, I only gave it a character, right? A pound sign. So it's going to output the pound sign 3 times because 3 is the default. And here I say the dollar amount and then count. I tell it 5 times, output this particular one. Okay? So hope, we didn't get through the whole chapter, but I hope up until this point functions are clear and they're making sense to you. Because next up we're going to talk about call by reference, call by value, and recursion. So that should wrap up this chapter, and then we'll jump into the next chapter. But I think this was worthwhile that we spend enough time on this so you get a good grasp of it.